This is the last lesson of the chapter. 16:3, day 4. Here we go. We got this. You excited? I'm excited. All right, here we go. More tangent to a curve, but we're going to do a little bit of a step up of the type of problems you're going to see. So, physical quantities can also be found using the idea of a secant becoming a tangent. And they ask you for the average rate of change, like the average speed or the average velocity or the average, whatever, average rate of change. It's going to be the secant line or the slope of the line between the 2 points. If they ask you for the instantaneous rate of change, meaning they want the rate of change happening right at this second, because, when we're in real life, we don't actually, like when you're driving on the freeway, you got to put your car in cruise control if you're going to stay at 65 miles per hour, right? Normally, your foot kind of comes up and goes down. And so it varies, right? So to find the rate of change for an instant, that's going to be your tangent line. So the limit of the slope of the line. And velocity is a rate. Velocity is the one we're going to talk about right now. And a position function will describe the path that an object takes, right? So position, where is the position of the ball or of the car or whatever. And then velocity is the rate of change of the position. All right, so let's talk about the motion of an object. And it's given by this function, f of t is equal to t squared minus 3t plus 5, where f of t is the height of an object in feet at t seconds, which makes sense. I've talked to you before, like this is a parabola. Well, except this is, okay, we're not going because, never mind. Let's talk about what is the average velocity of the object between t equals 2 seconds and 4 seconds. So if they're asking you for the average velocity, that's just the slope you have known your whole life. You are going to do f of 4, so the y minus y over x minus x, right? So f of 4 minus f of 2 divided by 4 minus 2. So average, if they're asking for average velocity, it's just the slope between the 2 points. Well, f of 4, you better plug a 4 in here. That would be 4 squared minus 3 times 4 plus 5. So 16 minus 12 plus 5, I plugged a 4 in there. Minus, and then put parentheses around it, plugging a 2 in would give you 2 squared, which is 4, minus 3 times 2 is 6 plus 5. And you're dividing by 4 minus 2, so that just gives you a 2. Simplifying this, what is that? A 4 plus 5 would give you 9, and 3, it looks like. Yeah. So 9 minus 3 will give you 6, divided by 2, which leaves you with 3 feet per second. So the average velocity of this object is 3 feet per second. Now, if they want to know the instantaneous velocity of the object at a specific time, so now we want what's the velocity when t equals 2? Instantaneous is the tangent line. You've got to find the slope of the tangent line. So that's, and you're going to be using f of t, because remember, it's m equals the limit as t goes to 2 of f of t minus f of 2 all over t minus 2. There we go. Perfect. Why did I say that out? Here we go. Slope is the limit as t goes to 2, because we're wanting at 2 seconds. You want f of t minus f of 2 all over t minus 2. All right, so f of t, you'll replace with the function, right? T squared minus 3t plus 5. You're going to subtract from it f of 2. We found it right here. You can just plug it in again too, though. 2 squared minus 3 times 2 plus 5. So you end up with, what did we figure out? A 3. So you've got the function t squared minus 3t plus 5, and then subtract from it 3. Well, then when you simplify the top here, it's t squared minus 3t plus 2, and then divided by t minus 2. And remember your goal. Like if you were to plug a 2 in right now, you're going to get 0 over 0. Not okay, right? So we're going to manipulate this algebraically. Whatever is in the bottom should be one of the factors. Yeah, so t minus 2 times what will give you this guy? T minus 2 times T minus 1. So the T minus 2's will cancel now. And now you're taking the limit of T minus 1 as T goes to 2. Plug that 2 in, and you get a 1 foot per second. So that's the instantaneous velocity right at 2 seconds. It's going 1 foot per second versus the average rate. Yeah, which that makes sense. It's a parabola. No, it's a parabola going down, whatever. Okay. Normally, the reason why, normally when we talk about height, like of a ball or whatever, it's normally an upside down parabola. This happens to be a opening up one. It's probably more that it's like a, whatever, I don't know. Okay, we'll keep going. And we're done. Nice. You're done. This is it. This was the last lesson. We're going to review some. I know it's craziness. Here's your homework, page 869, the classroom exercises. And then, and that's these guys are the classroom exercises and then the practice ones. Doesn't know, this is Isaac Newton, by the way, doesn't know how to describe the instant velocity of a body in movement, invents calculus just to describe it. Isn't he special? He was pretty special. All right. I hope you all are having a fantabulous day. Come see me in office hours. Bye.